Hello and welcome to week 2. This week's lesson is pretty much all about scattering. We're going to start off by putting some leaves on this tree. So if you open the file, it's just called beginning, or week 2 beginning. You'll see that we have a plane. We're not going to worry about that right now. Let's hide it. A trunk, because otherwise our tree would be floating in the air and that's not what we're after. And some branches, or stems, if you like. These are what we're going to scatter on. So let's look and see how Bifrost does scattering. First thing we're going to need to do is get these guys into Bifrost. Now, we did this last week. You can middle click and drag and drop, or you can select them in Maya. So you see they're selected and just create graph. And that mesh is automatically brought in as an input. So we can just call this branched, or branches might be better. Let's do branches. And so let's do the basics of scattering. You need to have this file, which we'll include in the description. So I'm going to go ahead assuming that you do. A really, really good habit to get into when you're working with Bifrost is anything you bring in, hide it. That way, when you're having a look at it, let's do that here, you're not going to end up with two things trying to occupy the same space. Something else you probably should do here is just make sure your lighting is set to use no lights or use flat lighting or default even. Because these guys are textured and right now they just look absolutely black. We'll be working on that one. We'll use default lighting for now. Let's just break this connection. You see that our stems disappear. What we want to do is we want to scatter some points on our branches. I'll hook this back up, and to do that we're going to use scatter points. So we'll plug this in, and while we're here let's take a look at what these points are doing. Now scattering is a method whereby I can take a geometry and just scatter points on the surface of that geometry. So let's throw down a point scope like this, which is going to let us have display options, and we'll output this to a terminal just so we can see what we're doing as we go. Now, by necessity, this is going to be a very basic tutorial, but you can see here the points have all turned up. Now, let's have a look at our scatter node. The name of the node itself is scatter points, like this. What you get in the heading is scatter by number and then random, because the heading is telling you what this is doing. So this is scattering by a number amount randomly. This is part of the name display. So if I just show name, scatter points comes back. If I show value, it's going to show me what that name is. Now, if you press T on your keyboard, it will start to put up the kind of nodes that they are. It's good to leave this on because then you can go, where's my scatter points? Oh, it's right there. Great. How does scatter points work? Well, it scatters points on a mesh, like I said. But specifically, how does Bifrost do it? Well, without getting too technical, you can always, as with any Bifrost node, you can jump in and see what it's doing. Convert amount to radius. Random scatter is where you're trying to get things done. If you jump inside, oops. If you jump inside random scatter, you can see more compounds. But scatter points on mesh is probably the one you're looking for. And if you wanted to, you can go through and follow the math there, and it will show you how Bifrost is doing this. What we're going to do is stay up at this level and just explain how this compound works, which is also a handy thing for you to know. So we're at a scatter point, and the first thing we should look at is, look, these points are all different colors. What's driving those colors? Well, the point scope is driving the colors, and the point scope is doing it by applying a color to a property, and the coloring property is a point normal. So how do these points get this point normal? And this is a really important thing to learn about Bifrost scattering, because you're going to use this over and over again. It makes life a lot easier when you come to get a bit more complex with your scattering. On the scatter node, if you have a look at the options, you'll see a properties tab, and under properties is transfer properties. And if we jump into the info, scroll down to properties, a space-separated list of geoproperties from the input geometry that are sampled and transferred to the output points. Only supports float, float 2, float 3, and float 4, but this is great because float is a value, which could be anything. Float 2 can be your UVs. You can sample your UV positions here if you have them. Float 3 are positions or colors, in this case, and vectors, in this case, normals, which are a vector, and these are the normals. And float 4 are things like colors with an alpha channel or orientations, things like that. This allows you to transfer properties from this tree to the resulting points. This will become super important as you try and do other things. And I'll try and show an example of this as we go. But for now, let's just set up the other half of this lesson, which is instancing. What instancing is that I've got these points, pop this up here for now, and I want to instance an object on them. And in this case, we want to try and make some leaves. So that's the next logical step. So let's go in here and we'll go create instances. Now, if you thought I just skipped over that, fear not, for I am coming back to it to talk about this some more. I just want to get this set up for now so we can all see what we're working on. When you create an instance, what you're giving it is a point object and something to instance on those points. And when I say instance on points, it's going to copy that object to the points with a bunch of rules that you set up, which I'll show you how to do shortly. What I'm going to use is this oak plane, which you should have in your outliner. Middle click, drag it in, turns up. And if I now hook this up into here to the instance geometries and connect this to the output, now you can see I have leaves on my tree. And these leaves have a texture. This all comes built in with this file. These leaves actually also have an alpha channel. And so there's transparency on the texture, which you can see, but if you go to your Viewport 2.0 and switch your transparency algorithm to alpha cut. Now you can see here that you have transparent textures, which is great. This is the basic setup. This is the basic setup for a tree. And now we're going to make it look a bit better. While we do that, I'll be showing you how we work with scattering and instancing. So I can still have a look at where my points are if I want. I've just got to hook them up to the transform. So I'm going to leave that point scope there, because I might be doing that in a minute. First thing I'd like to do is let's increase the number of leaves we have on the tree. We've got 1,000 right now. I think maybe we should go up to about 10 or 20 times that. It's 2,000. Now, if you've got alpha cut on, your viewport is going to slow down. And it's going to slow down a lot. The more points that you're instancing, the more alpha channels it has to deal with per object, the slower it's going to get. So what I do at this point is I pop back to my Viewport 2.0 and I just change this to something like object sorting, where I can now go ahead and say, okay, you know what I want? I want 20,000 leaves on this tree. And it's still almost instant to draw. However, if I go back here, and I apologize in advance if it crashes, and I switch this across to alpha cut, you can see already it's taking a very long time to work it out, and I cannot anymore orbit my object. The viewport is absolutely choking my scene here. So I'll let that come back and then quickly, or slowly, as the case may be, change this back to object sorting. Which is why, should you want to, you don't have to display the instances while you're working. You can swap that out with the points. And this will give you a good idea of where things are going to go. But there are some things I want to do with the instances first. Now, something you really, really solidly have to remember here is that when you create instances, even though I've put a plane on them, and I can put anything on there if I want to, I can change that to a mesh torus, for example. And I can replace that. And I've got 20,000 toruses. I have a brain tree, which is very nice. You notice here too, oh, and this is what happens when you don't instance anything. This is showing you the points right now that it's going to use to instance things on. If you notice, the instance geometries has 3 dots, boom, 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 on its input, which, as we learned last time, is a hat. Hat means it's an array. The 3 dots means it's a fan-in array, which means I can plug many, many things into it as long as they are all of the same type. We covered this last week. These ones are objects. I could plug an object array. I could plug single objects in there as well. So what I'm going to do is just plug them both in. So let's plug that in there and that in there. And it's a little hard to see, even harder there. So let's just shrink the old torus a bit so we can see things. But now you can see that I have a mixture of leaves and toruses, or planes and toruses. And I can just keep adding to that. So like, put a cylinder down like that. Can add that into the mix as well. Let's just make those a little smaller too. But I've got cylinders, I've got toruses, and I've got leaves. And if I wanted to say do something like I want green cylinders, I can assign a diagnostic material just to the cylinders, change this to a float 3, make it a bright green, and replace this here. You see my cylinders have gone green, my toruses are the lovely blue color, and my leaves have got a texture. So Bifrost gives you a lot of control over this just inside the instances node itself. And we're going to be doing something a little more complicated later when we come to work on our landscapes again. But for now, you can change how things are instanced. So right now it's sequential. What that means is that the first point is going to be the plane. Second point is going to be the torus. Third point is going to be the cylinder. Fourth point is going to be the plane. Fifth point is going to be the torus. It'll cycle. So it'll do 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, all the way up to 20,000 points. You can also change that to random. So now it's randomly choosing one of this from this array to instance on the tree. All good. Let's get this back to, this is just a quick, and you also have a probability curve. If I say just switch this across to a curve and push this up, you can see how we're getting more and more leaves as we go. Until from one point we get all leaves. What this is saying is, what is the probability of choosing one of these? Bring it back the other way, going to end up with all cylinders. And conversely, if I just bring this down to 0, this is going to give me all leaves again because it's all the zeros. But if I pop a point in at 0.5, I'm going to get another distribution that looks like that, as well as the ability to change a seed. That's real quick how instances are working. And we can add different things that will override this later. The other important thing about instances, before we go back to what we're actually talking about, which is scattering, is that you can preview things in different ways. So here's what I'm actually scattering. I've got some cylinders, some toruses, and some planes. What if I just wanted to see the bounding box of those? Because 20,000 isn't that many. 20 million is a lot. If I want to see the full geometry of 20 million points, things are going to get slow. But the bounding boxes will be a lot faster. And if you zoom in here, you can see that that one there is probably a leaf. Let's check it out. That's the one I was pointing at, definitely a leaf. Whereas these ones that have a little bit more volume to them, they're probably cylinders or toruses. Cool, so I'm just going to take my 2 of those out, so we're just left with leaves. That's great. And then I'll delete those. That's the whirlwind tour of instancing. There will be more. But now we're going to talk about scattering. So because we're going to talk about scattering, I'm going to go back to just seeing my points. We scattered on the stems, which are, if I select the Bifrost object, which are just these guys. Branches, stems, same kind of idea. And we are scattering 20,000 points. So if you take a look at this with a watch point, 20,000 points. So we're scattering 20,000 points randomly. What that means is I can change the seed to 197 and the positions will change. So this is just a random scatter. First, now I want to introduce you to the first scatter mode and probably the one we're going to use. So I'm going to change random to blue noise. And what blue noise does, we can check it out in the info tab, gives a blue noise distribution. This is also referred to as a quasi-random or low discrepancy distribution. Provides a more even distribution with points more equally spaced. You can kind of see that there. So I'll show you the difference. If we just keep an eye on what these points look like, change this back to random. And you can see how the distribution of the points are a lot more random here than they are here. These almost look like lines. Blue noise is great. The other one, blue noise maximal, is even better. If we go down to, it's a similar distribution to blue noise. It gives the most evenly spaced distribution, but it is very slow to compute. Let me show you. Select scatter, turn that to blue noise maximal. It's still computing. There you go. So that's given me the most even distribution that is possible to have with this number of points on this geometry. But it took a long time to compute that. Now, if you wanted to do this and then only calculate this on a single frame, this would be a good way to do it. But because my graph is going to be evaluated every time I make a change, what I'm going to do is pretty much cheat. I'm going to go back to blue noise, which is much faster to calculate, but gives a pretty good result. I'm going to turn my leaves back on. So these, it doesn't look much different now because there's a couple of things we need to do. But these are distributed a lot more evenly all over my branches. Great. And back to scatter. The max number here is basically a safeguard. If it's set to 1 million, if you're scattering 50 million points and you're trying to instance something really complicated on it, this will stop you from running yourself out of memory. So it will only show you this many, or only do this many. Moving down is the next, I'll close that up so we can look, is the next useful thing we have here, which is culling. Again, check the info tab. I'm going to keep doing this because it's a really good habit to get into. Let's find culling. So culling controls the interpolation of the density weights parameter. Where's the density weights? Well, that's what we need to talk about. Here is the density weights. I'm going to show you how this works in just a second, but for now, remember that you have two options here. You can have random weights, random density weights, or distance-based density weights. Nothing's going to change until I've plugged something in there. Randomly deletes points that are too close to other points. Just hold that in your mind for now while we keep going. We're going to then go into cull overlapping, remove points that are closer than 2 times overlapping radius units. Pretty much means, if I turn that on, you can see I've lost a lot of points. Let's jump back to points for now for this, just for quickness, because it'll be easier to see. We're still scattering 20,000 points, but we're only seeing 2,106 of them because all of the rest are inside this radius from another point. If I increase this radius, we're going to get less and less points. If I decrease it, maybe don't go negative, it would be a bit silly. But if I decrease it, we're going to get more and more points. So this is just another way of culling overlapping points should you need to, based on a radius. Let's turn that off for now and pretty much get back to what we had. And this is where we're going to talk about density weights. What density weights allows you to do is control how much is scattered where. And this is a really good feature to use. So these are the branches on a tree, or they're going to be. Really what we'd like to do is have less leaves down the bottom and more leaves as we go out and towards the top. Now, because we don't have I'm just going to hide my Bifrost for a second and show the stems. Because we don't have weights on these stems, it's going to be really difficult to say, well, look, I want nothing close to the tree and more as you get out to the edge. So what we'll do is fake that instead. What we're going to say is like, okay, look, I need to get the Y position of these points. Well, the Y position of the points I'm scattering on. And I want to scatter less points the further down they go. And this is really similar to the displacement we did on our landscape. So what I need to do here is I'll need to get my point position and do a vector to scalar. And remember, you can just type in VTS, we'll get you there. You're looking for tabs. And what I'm going to do, because of the way weights work, they're a 0 to 1 thing. And you can see it, there's a really good explanation here in the info tab. It says weights per point are the input geometry to control the distribution of generated points. So if you have a weight of 0, no points, 0 or less. So -2, no points, -200, no points, 0, no points, 0.5, half the number of points, 1, all the points you want to scatter, 250, all the points you want to scatter. So it's really a 0 to 1. And the thing to remember is that this is an interpreted autoport, which means I can put in anything that's basically a float. So you can see here, this is what I'm able to put in. So I can put in a float, a single float number. I can put in, so if I say make a value, let's make that value 0.5, pop that in there, and I'll lose half my points straight away. And that's controlled by this. So right now I've lost half my points randomly. If I change that to distance based, I've lost half my points based on their distance to another point. And that's with a single float. If we go back to our info, we can put in an array of floats, and that's what I'm going to do with these guys. So I'm going to take my Y value, I'm going to do an array bounds. So I'm going to remap these to a 0 to 1 range. So right now the Y value of all of the points on these branches is from some number to another number. I'm going to change that so they're from 0 at the lowest point to 1 at the highest point. We'll put that into from start and that into from end, and then we'll just make sure here that we've got a 1 in our end. So let's see what this does. So I'm just going to grab this and all of this actually and move it around. So let's just see what this does. And you can see that we've got less points at the bottom and more points at the top. And you are absolutely quite able to see this and use, make yourself a little visual aid that will help you with this. We'll do that now. So if you see down here, we're just outputting the branches straight out, and that's what's showing us these black branches here. We're going to assign a diagnostic material to those branches. And because this is another interpreted port, I can actually plug a float into it, and it's smart enough to generate a vector for me. And you can see, let's just hide the trunk for now. And maybe we'll just even hide the scatter. You can see right now that it's black down here and white down here, which means, what we probably want to do, as well as remap, is adjust. And we do that with, same as we did last week, evaluate F-curve. Handy dandy thing to have. This will allow us to adjust our array based on this curve. So if I straight out go in here and just go, okay, do that. You can see that my white and my black, it's a lot whiter at the top, it's a lot darker at the bottom. And I can mess around with that. So if I only really want the very tops of it to be white, I can do this, undo that. Or if I want to get less at the bottom, I can do all kinds of things. Like I can say, I don't actually want you to have any leaves below about there. See how this is working. Let's hook this up to the weights as well, and we'll turn our points back on. You can see that there's no points here at all, and they're getting denser the further up the tree you go. Like I said, it's an imperfect solution. We don't have any way to set the density on these branches, but there are ways to do that too, depending on where you get your branches from. So you'll be able to see the colors and the points change when you change the F-curve. So for example, if I say what I want coming out of this at 0 is negative 0.5. Boom. No points. No points at all below that level, with a smooth graduation up to all of the points up here. Because we went below 0, the density weights input says, okay, no points there. Let's fit that graph. In fact, let's pop that out into a window so we can look at it a bit better. I can say, take that guy back up to 2.5, and you can see the representation of those weights change. Do something like this, and I'm just going to mess around with it until I get something I like the look of. Maybe I want a few more up the top, something like that. Cool. And at this point, I can plug my instances back in. And it still looks kind of weird because we haven't set up our instances properly yet. But that's okay, we're doing scattering. And if you wanted to just be able to switch something on and off, we did this last week as well. But hey, reiteration's never going to hurt. Put that into the true case. We'll grab this guy, put him in the false case. And now if we want to switch on the display, we just turn the condition on and off like this. All good. Leave it off for now. So let's say this is pretty much what I'm after. I've got less leaves down here than I do up here. So we're getting ready to start doing things with our instances. So let's call our scatter done. There are some other options here we should talk about first. This one, and this one for now are the most important. Okay, so scatter mode is how are you scattering? Random, blue noise max. Amount mode, number. Right now I'm saying I want 20,000 scattered randomly on this geometry with this seed. And I can keep changing that seed. The weights are still going to do their thing. So 128, it's fine. There's a bit of a binary geek over here. You can change the amount mode. So again, let's see what the info node says about it. Come past the weights. Oh, almost forgot. You can put a string into your density weights. So if, for example, I did have a property that was on my mesh that gave me the proper weights for leaf scattering, whether I painted it or what, then instead of putting in this array of floats, I could put in the name of that property, and the node is smart enough to pick that up and use it. It's a really good thing. Scalar field. We did some fields. You guys know what a field is. You know what scalar and vector fields are. Scalar is the float field. It outputs floats at a point in space. We can plug one of these in there as well. So let's do a fractal noise field, which is our, happy go-to anyway. Plug that into here. And there's our weights there. See, it's changed. If I come in here, I can change the magnitude. You can see there are more and more points being added. I can bring my frequency down, so you've got bigger clumps of leaves, or up, so you've got smaller ones. And again, increase the magnitude. So this is more of a random noise that we're putting on here. There are ways to do this with fields as well, but that's probably a little outside the scope of this particular tutorial. Advanced fields is advanced fields. But you can just use a field here. Interpreted autoports are awesome, and something I would recommend everybody get their head around. We have this set up the way we want it in terms of density weights. We can take a look at those weights by switching on our display. And of course we can see the results of our weights by where our points are. You can see there's more. The further up you go, the more points there are. The further down you go, the less points there are. Allows you to turn that on and then adjust the curves you've made or whatever it is you need to do. So you want more points coming down, you can see that working, less, etc., etc. I find this a good workflow for when I'm working with scattering points because it just involves the points. It's a lot faster just to display the points than it is to display the final results. But for now, we need to do some things to our instances. Let's plug our instances in. So here we go. We have all of these planes scattered on this tree. I can, again, if I want to, it's going to hurt. I can go and turn that to alpha cut and I'll get a much better idea. The reason it's a lot faster is we're now culling our points because we're using density weights to control it. So while we are still scattering 20,000 points, we're only seeing, if you give it a second, 4,146 elements. So what the weights have done has taken away 16,000 of these leaves. Now this is just a bit slow for me, so I'm going to put up with having no alpha. Let's get it simple. It's the fastest one. And there's a couple of problems here. First off, all of these leaves are the same, exactly the same size. So they're exactly the same object instance over and over and over on the points. First thing I want to do is change that. And this is where realizing that coming out of a scatter and into an instance, this is point information. And so is this, the output of an instance as well. There's a little bit of a difference here when it comes to things like outputting for a game engine through USD. You don't have to bake the instances, but we'll get to that later. Right now, what I really want to do is make those different sizes. So I've got a compound for that, which is randomize point scale, which pretty much does what it says. Points in, out points, and you can see now we have different scales. We have this little one here, we've got this big one here. If you take a look at the settings, that's the minimum scale, the maximum scale, and the seed for the random scale. You've also got access to scale, so you can scale each axis uniformly, each axis separately, which will give you stretching, or just one axis. It's the y-axis, the x-axis, and the z-axis. We're just going to go for uniform. And you can scale existing values. So if I turn that off, it's going to, and at the moment the existing values are 1, so it didn't really matter. But if I turn that off, it's going to scale between here and here. If I turn that on, it's going to scale between 0.5 multiplied by what was on there already, or 2 times what was already on there. So we can now mess with these to get sort of the look we want. I think some of these are a bit big, so I'm going to take the top down to 1, and I'm going to take the bottom, and yeah, you can just slide these down to about 0.3, 1/3, 0.33. Like that, because down here you have a distribution. So this is basically telling you how much scale to have. If I bring this along, you can see I've got lots and lots and lots of little ones. And at the moment, they're all ramping up from the little ones to the big ones properly. I can change the big ones. Putting it up that way would give me lots and lots and lots of the big ones. Undo that. Come back to here. So what this is saying is I want quite a few of the little ones that then ramp up quite quickly to not so many of the big ones. So we can change that. Absolutely change that. We can say I want it to scale very quickly, and then I want the top to be quite uniform and have quite a lot of them. And of course I can always do this too. So I just reverse the 2 scaling numbers. Or if I wanted to, I could reverse that ramp and the same thing would happen. Randomize point scale, I had 0.33. And of course, if I select here and here, I can change them both at the same time, but keep their relationship to one another, which is really cool. Mess with my seed, and I'm starting to get a few more random bits on my leaves, which is great. So what I actually want to do is I'm going to take that back to 1. I'm going to take this up to about 0.5. So there's not terribly much difference in the size of the leaves, or I could go 0.25, 0.5, and you get the same idea. Again, there's still only about 4,000 of these. We would need to change our density weights here to get a different one, but I'm finding that this is quite good to show what's going on. Please make a better tree than me is what I'm saying, please. But right now, this is a good way to show you how everything works. So the other thing you might notice is that pretty much all of these guys are pointing along the normal that they've picked up from the mesh, which is cool. We told them to do that, and the part in scatter that controls that is the orientation, which I deliberately didn't say anything about. Just after the transfer properties, there's a specific subsection on orientation. If I turn that off, all of a sudden the orientation goes absolutely straight back to what it was when it has no normal. If I show that plane, you can see there's the plane there. This is what we're actually scattering onto our tree. And this plane is sitting like this, and these are all the same like it, because we're not calculating any orientation from the geometry. Click that on. And now these guys are picking up the normal from where the points have been scattered. So this is coming from the points and rotating these instances along that normal. It's setting the orientation for. There's 2 ways to do it. You can go to a face vertex normal. It isn't going to change anything right now. Or a point normal, which is the thing we want right now. And then you can calculate the tangent by connectivity of the mesh, which will give us this. And this is calculating the angle that these leaves sit at based on the tangents between the nearest point and the nearest point to that, basically, or generate it from UV, which is what we're doing now. You can also say, I don't want to prioritize my normal. You see some of them are changing. That way it's calculating the orientation without prioritizing the normal and with prioritizing the normal. Just a bit of backstory. All that to say is we've got another randomized point here, and that is randomized point rotation. Drop that in, and all of a sudden we have randomized our rotation by this amount. It's cool. So start getting used to working in radians, and remember that a radian is just another way of measuring a circle. Okay, So if I remember rightly, 2 times pi is 360 degrees. Correct me if I'm wrong. I will look that up before I finish the editing and publish that statement. So right here, we're going from negative pi, 3.14159, to positive pi, 3.14159, which gives us 2 pi. If you add the absolute value of those together, we'll get the difference of those two. You get 6.29 or 6.282, whatever it is, which will give us a whole circle in the y. Okay, and we can start seeing how that works by just changing these numbers. So you see that they're only rotating around the long axis of the leaves, which is what we want. However, we have the ability to also rotate them that way and that way. Again, with random, this is generating a random number. There's a distribution. There's a rotation order as well. There's also rotate existing values, which you probably want to leave on in this case. And there's local space. If I turn off local space, it's not going to look as good. And it's rotating in world space. We want it to rotate in local space, so we'll turn that back on. So now, all of a sudden, I'm getting something that looks a bit more like an actual tree. If I was to just bypass this, show you what we had, you can see that these are all lined up. Boom, 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 boom. And what we want to do is, trees don't quite do that. Trees are a lot more like this. And as you can still see by the density is still on, I can still go back here because procedural, because non-destructive, because awesome. I can still go back here and change the scatter density. And everything else is going to ripple through and just, you can see how you're getting less and less leaves, more and more leaves. Everything's just going to ripple through and behave the way it's supposed to. Let's get this back to where it was and that a bit smaller so we get some real estate, and probably don't need our outliner for the last 25 minutes or so. So this is the basis of scattering. At this point, you would take your plane, let's see, Arnold, mesh settings, plug that into there, and then plug that into your instances. You see nothing changes, but this just allows you to change how things are going to be rendered in Arnold. Very handy thing if you are rendering in Arnold. And before you render this, you could render this now. It's reasonably smart. I click here and just switch over to Arnold, and I make sure it's just doing a render at the moment. It's having a thing. So we have no Arnold lights right here. Arnold lights, Skydome, it's a good thing to do. See the leaves? You can even see the texture on one of them, but it's not coming through on these ones. We've still got our leaves, but Arnold doesn't quite know what to do with them at this point. So we do need to assign a shader to them. So if we assign material, well, before we do that, we need to bake them. So if I bake instance geometry here, comes into the instances, goes out through the merged meshes, and let's be smart with Arnold and just plug this guy into the final so that the render actually picks it up. Now we have leaves on our tree. We don't have the right sort of transparency on the leaves on our tree, but we have leaves on the tree. And this would be the same as if I plug this in here. Turn this off. Having a render doesn't quite look right. It will render our instances for us without baking them. What we need to do is put the right shader onto this. There's the shader right now. We're going to have a little bit of a very quick Maya lesson. I'm going to go to my hypershade. It is, and it's Aspen. I need oak. So this is the shader we're using. You can see it's got an alpha channel. It's got a texture, so I can assign material. It goes into the geometry, comes out there, and I can quite simply middle click and drag this across to here. So this is this shader inside Bifrost, and then set that to my surface material. Because our material is correct, we now have leaves on our tree. So that's how you do this for a rendering pipeline. Nothing changes in terms of everything up to this point. You can see now that it's actually rendering the instances, not the baked instances. Because we put the shader on, everything's behaving properly. Everything's looking good. What we're going to go on to now, now that we're starting to get our head around scattering, is we're going to go on to doing this outside of a render pipeline for more game assets or being able to get a scattered environment into a game. One thing I wanted to show you before we go ahead and do that, just to finish up on the scattering, is that both point scale and point rotation have weights. And you know what I'm going to do? I'm going to go in here and look at the weights. What happens if you put weights on this one? Controls the amount of randomization applied. So this is basically saying how random is the scale. And this is saying how random is the rotation. And you've got the same explanation here. The info tab on all of the scatter stuff is very, very good. Very, very good. Now, last thing, what happens if I go in here and I'm just going to take this amount right down to 2. Almost no leaves. We'll let Arnold do its thing. It won't take long. Almost no leaves or absolutely no leaves. Because they probably all got, the weights still apply, right? But if I now change this number to density, I'm starting to get some more leaves. And if I change the amount to 10, even more, 50, lots more, 200. And now we wait, but we've got a real tree. Density is a different way of scattering. And we're still applying the weights to the density. Density is how it scatters in the first place. If we check the info tab while that render does its thing, random, which is what we're using, uniform pseudo random distribution. So we're randomly scattering. That's what we want. Oh, that's scatter mode, sorry. Come down to here, look at the amount mode. Number, which is what we did, just simply generates the number we put in, generates the amount number of locations. We're on density right now, generates the amount locations per unit of surface area, strand length, or volume. This is a surface that we're scattering on, not a strand or a volume. So what it's basically looking for is, or what it's scattering is, it's scattering points or locations per unit of surface area. So it's looking at the surface area of the mesh that we're scattering on and adjusting accordingly. Radius generates locations that are spaced at least 2 times amount units apart. Okay, so if we come back to our parameter tab, let's just play it safe, get that down to 10 again. Change this to radius, nothing, because it's scattering 20 units apart. We go to 1, a couple of leaves turn up. If we go to 0.5, more leaves turn up. 0.05, lots of leaves turn up. So they're just different ways, depending on what you're scattering on, to get a different scatter. So that's the hardcore scatter, including rendering, where you need shaders, where you need things like that. Real hardcore and start dropping that number precipitously. And you can see it's getting denser and denser and denser, but it's still obeying the weights that we've plugged in. There are still no leaves down here. There are still less leaves here than there are here. It's still doing the scale and rotation. It's making a tree. We can go lower still. It's going to start to hurt and we might start hitting our max number shortly. But it's procedural. Everything ripples through. Everything that we've set up to apply to it still applies. Look at that. There we go. Lots and lots and lots of leaves now. Still randomized, still scaled. That's looking more like a tree, but it's also taking a lot longer to render. That's basically the raw scatter and instance pipeline. We're going to go through some more, which allows you to randomize this even more, but we're going to do this in more of a game, low poly, low overhead environment where we don't need to worry so much about shading and rendering, just UVs, textures, things like that. I'll just let that render finish and then we'll get straight onto it. So let's just reload what we did last week.